Welcome. This presentation concerns a demonstration of the R computing language. I'm bjmchugh. Previously, it was demonstrated how Linux tools could be used to probe wireless devices. Then it was demonstrated how the R computing language could be used to extract and depict wireless information. In this presentation, the R computing language will be used to extract Hobo Valley Regional School District line item budget information from the 2008-2009 school year. It is my hope that community members will contemplate the extracted information. The line item budget was supplied on May 21, 2008 based upon an OPA request. It is in tabular format and there is a description column. An explanation of codes file was provided with the line item budget. Functions in R are followed by a list of arguments in parentheses. The function scan is used to read non-tabular information. The function read.csv will be used to read the tabular line item budget information. One argument specifies the file to be read, one specifies the separator, and one specifies the column classes. I explicitly instruct R to read the information as character strings because R is an interpreted language and I wish to guide interpretation. Adjacent less than and hyphen characters assign the read information to an object. I use RB to represent the read budget, and RE to represent the read explanations. The function names with the object as the argument displays the function name, the column names. One sees a list of the names vector and their positions displayed in the brackets at the left. Brackets following an object are used to identify or extract objects. In this case, the object was read as a data frame, which is similar to a matrix. Consistent with matrix notation and computer language syntax, the first bracket index represents the row, the second represents the column. The object residing in the 39th row of the first column of the explanations file is extracted. The objects residing in the first row of the first through the fourth columns of the line item budget are extracted. The colon is a through identifier. The names function and extraction were demonstrated. The explanations file has a code column comprised of a 2-digit field followed by 3-digit fields separated by hyphens. The line item budget file has separate fund, program, function, and code columns. These four entities represent the code column entity of the explanations file. Furthermore, when the program column is 0, only 1 digit is used rather than 3 digits. Before the advent of computers when information was manually processed, the line item budget file and explanations file pair might have been acceptable. After the advent of computers when information is automatically processed, this is unacceptable. Fortunately, computer code can be written to improve poorly thought out processes. First, if the program field is a 1-digit 0, it is replaced by 3 digits of zeros. Then, a combined line item budget field is created comprised of the concatenation of the first 4 fields separated by hyphens. Next, one can use the pmatch function. The arguments are vectors. Pmatch strives to match the pattern of every item in the first vector to items in the second vector. The intent is to match the code column of the explanations file with the combined column of the line item budget file. Unfortunately, it can be seen that 470 out of 543 line item budget combined entries have no corresponding explanations code entry. Therefore, the line item budget description field will be used to make sense of the information. The R computing language conveniently uses Unix capabilities. The grep function originates from the Unix command library. The first argument of the grep function specifies a pattern. The second specifies the vector of items in which to search for the pattern. The line item budget has 543 entries or rows. Each column is a vector of length 543. In essence, each description vector item will be searched for the string com. It was found in the following positions. These positions can be used to extract the description and the amounts corresponding to where the string com was found. Since computers automatically process numbers and have no need of commas, the use of function gsub is used. The arguments specify the characters or symbols that should be replaced by the preferred characters or symbols. The as.numeric function is used to convert the character string to a number. Notice the lack of quotation marks. Finally, one can produce a bar plot. In his presentation to the Board of Education on January 12, 2009 regarding the 2009-2010 budget, Thomas Butler warned of increasing telecommunications costs. Almost exactly 1 year before, on January 14, 2008, Hopewell Valley announced the board-approved plan to switch phone carriers from Verizon and AT&T to the Marlton-based Xtel Communications. The switch was to have occurred over the 2008 spring break and was to result in $56,000 a year savings. Although I can't explain why the 2008-2009 line item budget from May 21, 2008 doesn't reflect this, I do expect the 2009-2010 line item budget to reflect a $56,000 credit in addition to a $56,000 reduction in telecommunications costs. By the way, when telecommunications costs are reported, shouldn't consultants' fees and equipment costs, that is phones and switches, be reported with the service fees? The same can be done for technology costs. This time, the description column is searched for the character string TECH, tech. One can see the corresponding descriptions and amounts, and one can produce the bar and the bar plot function can be used for a graphical depiction. Hopewell Valley anticipates the life of Windows, Mac OS operating system computers to be 4 years. Linux extends the life of computers beyond 8 years. The computer I use for my internet gateway is an IBM PS2. It has an Intel 486 and is 18 years old. The computer I use for my everyday tasks is a Compact Desk Pro. It has an Intel Pentium 3 and is 10 years old. Open source software can perform a wide variety of tasks and is free. I would be interested to hear the reasons from anyone associated with the Hopewell Valley Regional School District why $500,000 couldn't immediately be cut from the technology budget without adversely impacting education. For the people residing in the Hopewell Valley Regional School District who believe I'm not polite because I speak so candidly, I have the following question. Do you consider yourself a responsible community member if you cannot provide technology spending justification and are unwilling to demand it from the Hopewell Valley Regional School District? When attempting to investigate transportation costs, the description column is not as informative as it was when investigating communications and technology costs. More specifically, there is no common transportation string. I can only hope that I extracted all the appropriate communications and technology line items with the strings I used. Through manual inspection of the line item budget, transportation costs are believed to reside from the 268th row to the 313th row. In this case, extraction is performed by explicit row identification. One can notice the absence of a common transportation string in the description/amount listing. According to Robert Calavita, the most recent board-directed busing analysis was performed by an ad hoc transportation committee more than a decade ago. As you saw, 2008-2009 line item transportation costs for about 3,200 students amounted to be $4.2 million. This is a major expense. If one searches YouTube for videos by bjmchugh 1256, the August 18, 2008 clip shows the school district claiming it to be infeasible to share services with the township. Later, I learned of a willing offer by Paul Pogorzelski, the township administrator/engineer, to share township storage space, gasoline purchasing, mechanics, etc. with the school district. Shouldn't the board request an updated transportation plan and associated costs from the school administration?